أعزائي طلبة وطالبات الثانوية العامة القسم العلمي رياضيات لغات، أهلا بيكم في حلقة جديدة من حلقات برنامجنا برنامج داينامكس. النهاردة إن شاء الله هنستعرض موضوع جديد من موضوعاتنا، وهو موضوع motion of the body on a smooth inclined plane. Dear students of grade 3 secondary, welcome to our math program. Today we have dynamics. Our lesson today is motion of the body on a smooth inclined plane. Motion of a body on a smooth inclined plane. Let a body of mass m moves on a smooth inclined plane. Incline to the horizontal with an angle of measure theta. Under the action of a force of magnitude F, acting in the direction of the line of the greatest slope of the plane upwards. Then we note that the body is under the action of the following three forces. Number one, the given force and acting in the direction of the greatest slope to the plane upwards, and its magnitude is F. The second force, the weight of the body acting vertically downwards of magnitude mg. The third force is the reaction of the plane acting in a perpendicular direction to the plane upwards and of magnitude n. By analyzing the weight into two components, two perpendicular components, one of them is in the direction of the plane downwards, and the other force or the other component is in perpendicular direction to the plane. Then the component is in the direction of the plane equals mg sine theta, and the component is in the direction perpendicular to the plane equals mg cosine theta. Then we have three cases. The first case, if the magnitude of F bigger than mg sine theta, mg bigger than the component of the weight in the direction of the plane downwards. In this case, the body moves with a uniform acceleration upwards the plane, and the equation of its motion is ma equals F minus mg sine theta according to Newton's second law. If the action of the force F is ceased after passing time t from the beginning of the motion, then the body moves upward the plane in the same previous direction, but with a retarded acceleration a dash, where a dash equals negative g sine theta, because F equals 0, ceased is meaning the force equals 0, and we can cancel the mass of the body from the two sides. Then a dash is equals negative g sine theta. A dash here is a retarded acceleration or deceleration. The body reaches the maximum height and comes to rest. Then it changes the direction of its motion downwards the plane with an increasing acceleration of magnitude a double dash equals g sine theta. The body here moves under its action of its weight only. Now the second case. If F smaller than mg sine theta, then the body moves with a uniform acceleration downwards the plane. and the equation of its motion is MA equals mg sine theta minus F. And the third case, if the magnitude of F equals mg sine theta, then the body preserves its rest state on the plane, but if the body has acquired a uniform velocity v in the direction of the plane, upwards or downwards, then the body moves on the plane in the direction of vector v with a uniform velocity according to the Newton first law. Here the acceleration of motion equal 0. Example: a body of mass 12 kg is placed on a smooth plane inclines at 30 degrees to the horizontal. A force of magnitude 88.8 Newton acts in the direction of the line of the greatest slope upwards the plane. Find the velocity of this body after 14 seconds from the beginning of the motion, and if the force acting on the body is seized at this moment, find the distance which the body moves on the plane after that until it's at rest. Now we have a body of mass 12 kg placed on a smooth plane inclines at angle of measure 30 to the horizontal, and a force of magnitude 88.8 Newton acts in the direction of the line of the greatest slope upwards the plane. Then F equals 88.8 Newton, and the initial velocity v naught equals 0, and the mass of the body equals 12 kg. The force acting for 14 seconds. Then mg sine theta equals 12 times 9.8 sine 30 equals 58.8 Newton. Now we have the magnitude of the force is 88.8 Newton, and the magnitude of the component mg sine theta equals 58.8 Newton. Then F is bigger than mg sine theta, and the body moves upwards the plane with a uniform acceleration a. Now the equation of motion of the body. The body moves upward, then ma equals F minus mg sine theta. Mass of the body equals 12 times the acceleration a equals the magnitude of F equals 88.8 minus the magnitude of mg sine theta 58.8. Then the acceleration equals 2.5 meter per second square. Now v equal v naught plus at, the velocity after 14 seconds. V equals v naught, the initial velocity, equals 0 because the body is placed on a smooth plane. Then the initial velocity equals 0. Then the velocity v equals 35 meter per second. After leaving the action of the force, the body moves in the same previous direction with a uniform retardation a dash. What is the equation of the motion in this case? m a dash equals negative mg sine theta. Then m a dash equals negative 12 times 9.8 times half. A dash equals negative 4.9 meter per second square. The body travels a distance s meter until it comes to rest, where V squared equal V naught square plus 2A dash S. The velocity equals 0 at rest, and the initial velocity in this case equal 35 meter per second is the final velocity in the first stage. 0 equals 35 power 2 plus 2 multiply A dash, which equals negative 4.9 meter per second square times S. Then 9.8 S equals 1225, and we get the displacement equals 125 meter. Now we move to the next example. A body of mass 25 kilogram is placed on a smooth plane inclined with an angle of measure theta, where tan theta equals 4/3. A horizontal force of magnitude 30 kilogram weight acts in the direction of the plane, and its line of action lies in the vertical plane, passing through the line of the greatest slope to the plane. Find the generated acceleration and the magnitude of the reaction force of the plane. Now we have a body of mass 25 and a force of magnitude 30 kilogram weight acts on it. Then F cosine theta, the component of the force F in the direction of the line of the greatest slope upward, equals 30 times 9.8 times cosine theta equals 3/5, equals 176.4 Newton. And mg sine theta equals 25 times 9.8 times 4/5 equals 196 Newton. Then the component of the force in the direction of the line of the greatest slope upwards, F cosine theta, smaller than the component of the weight in the direction of the line of the greatest slope downward the plane. Since F cosine theta smaller than mg sine theta, then the body moves downward the plane with a uniform acceleration A. Now we can write the equation of motion of the body. MA equals mg sine theta minus F cosine theta. What is the magnitude of the mass? 25 times the acceleration A equals 196 minus 176.4. Then 25A equals 19.6, and the acceleration equals 98/125 meter per second square. Now the second required is the reaction of the force on the plane. The reaction force of the plane N equals mg cosine theta, which is the component of the weight in the direction perpendicular to the plane, plus F sine theta, which is the component of the force in the direction perpendicular to the plane. Then N equals 25 multiply G, which equal 9.8, times cosine theta, which equal 3/5, plus the magnitude of F in Newton, 30 times 9.8. Note that the magnitude of the force equal 30 kilogram weight, but in the equation of motion, the force must be in Newton. Then 30 kilogram weight times 9.8 is the magnitude of the force in Newton. Multiply sine theta, which equals 4/5. Then N equals 147 plus 235.2. Then N equals 382.2 Newton. What is the magnitude of the reaction in kilogram weight? N equals Newton over 9.8 equals kilogram weight. Then N equal 382.2 divided 9.8 kilogram weight, which equals 39 kilogram weight. Then the reaction of the plane equals 39 kilogram weight. Another example. A body of mass 30 kilogram is placed on a smooth plane inclines at 30 degrees to the horizontal under the action of a force of magnitude F Newton. The direction of the force in the direction of the line of the greatest slope upwards the plane with an acceleration of magnitude 1.5 meter per second squared. Find the acceleration by which the body moves on the same plane under the action of a force of magnitude half F Newton and acts in the direction of the line of the greatest slope upwards the plane. Now we have two cases. A body of mass 30 kilogram placed on a smooth inclined plane to the horizontal with an angle of measure 30 degrees. The magnitude of the force acting on the body, F Newton, and its direction is in the same direction of the line of the greatest slope upward the plane. The mass of the body equal 30 kilogram. Now, mg sine theta equals 30 times 9.8 times sine 30, which equals 147 Newton. Then F is bigger than mg sine theta, then the body moves upward the plane with a uniform acceleration a. Now we can write the equation of motion of the first case. The first case, the body moves with force of magnitude F Newton, then MA equals F minus mg sine theta. 30, which is the mass of the body, multiply 1.5, the acceleration of the body. Note that the mass in kilogram and the acceleration in meter per second square, then the force must be in Newton, equals F, the magnitude of the force in Newton, minus 30 times 9.8 sine 30 degrees. 30 times 1.5 equals F minus 30 times 9.8 times 0.5. Then the magnitude of the force equals 192 Newton. The magnitude of the force is 192 Newton in the first case. The equation of motion of the body is MA dash equals half F minus mg sine theta. In the second case, the body moves under the action of force equals half the magnitude of the previous force, half F, and the direction of this force upward the plane, and the body moves upward the plane with a retardation acceleration. Then MA dash equals 30 times A dash, half times the magnitude of the force equals 192 minus 30 times 9.8 sine 30. Then 30 times A dash equals half times 192 minus 30 times 9.8 times 0.5. 0.5 is the value of sine 30. Then the acceleration equals negative 1.7 meter per second square. Now we note that the acceleration in the first case equals 1.5 meter per second square when the body moves on the plane, smooth plane inclined to the horizontal with an angle of measure 30, and if the force acted on the body equals half the magnitude of the first case, then the acceleration equals negative 1.7 meter per second square. What a meaning of negative 1.7 meter per second square? The acceleration here is negative. This means the velocity of the body is decreased until the body comes to rest and changes its direction of motion and turn and move downward the plane. Another example. If a body moves on a smooth inclined plane and inclines with an angle of measure theta under the action of its weight only, then its acceleration of motion equals to g cosine theta, g sine theta, or equal 0. Now we have a body moves on a smooth inclined plane, inclines to the horizontal with an angle of measure theta as shown in the opposite figure. Then the body moves under the action of its weight only. Then what's the value of its acceleration in this case? We have a body of mass m. The weight equals mg. The two components of the weight, mg sine theta in the direction of the line of the greatest slope downwards the plane, and the other component, mg cosine theta, in the direction perpendicular to the plane. And the reaction of the plane on the body equals n. The body moves downward the plane because the body moves under the action of its weight only. Then what is the equation of motion in this case? In this case, ma equals mg sine theta. Mg sine theta is the force acting on the body in this case. We can cancel the mass from both sides. Then the acceleration A equal g sine theta. Then if a body moves on a smooth inclined plane and inclines with an angle of measure theta under the action of its weight only, then its acceleration of motion equals to g sine theta. بكده أعزائي نكون استعرضنا مع بعض موضوع motion of the body on a smooth inclined plane، وعرفنا ان طالما البلين سموث يبقى ما عنديش اي فريكشن فورس، يبقى عندي فقط الفورس اللي بتحاول تحرك البادي اللي هي الاف، وعندي كمان الكومبوننت بتاعت الويت اللي هي ام جي ساين ثيتا، ودول شغالين هما الاثنين parallel to the line of the greatest slope of the plane. وعندي كمان الكومبوننت بتاعت الويت ام جي كوزاين ثيتا، ودي تبقى perpendicular to the plane. وعندي كمان الفورس اللي هي الرياكشن بتاعه البلين on the body اللي هي n، ودي perpendicular to the plane upwards. ببدا اكتب الايكويشن اوف موشن بتاعتي واشوف البادي اول حاجه هيتحرك upward the plane ولا downward the plane، ومن هنا ببدا احدد الايكويشن بتاعتي عشان اعرف الدايركشن. انا هشغل نيوتن سكند لو اللي هي ام اي ايكوالز اف. الاف هنا مقصود بيها مين؟ مقصود بيها الريزلتنت بتاعت الفورسز اللي شغاله على البادي. فلو في اف وفي ام جي ساين ثيتا يبقى الريزلتنت بتاعتهم هي الاف اللي شغاله على البادي. ابدا ساعتها اشوف هو البادي هيتحرك upward the plane or downward the plane، وابدا اكتب الايكويشن واحل المساله بتاعتي بكل بساطه وسهوله. Dear students, by this example we come to the end of our program today. Till we meet again, it's goodbye.